In 1965, Hinde engineers at Bell Labs pointed an antenna at the sky to find the source of a hiss they could not remove, and they found the afterglow of the beginning of the universe. A satellite called OMAP mapped that afterglow across the entire sky and found it was almost perfectly smooth, varying by less than 1 part in 100,000. In hangin komcham, a mathematical physicist named Roger Penrose looked at that same map and claimed to find something that should not be there at all. 28 circular patches, brighter than they had any right to be, scattered across the oldest light we have ever measured. And despite 95 years of the best instruments the human species has ever built, we still cannot agree on what those patches mean, because answering that question would require admitting that the Big Bang might not have been the beginning of anything. That sentence should bother you, not because it is exotic, because it is not supposed to be possible. You were taught, correctly, that time itself started at the Big Bang, not just matter, not just space, time. And if time started there, then the phrase "before the Big Bang" is not a mystery waiting to be solved. It is a grammatical error, like asking what is north of the North Pole. That is the idea I want to spend the next 20-some minutes taking apart, brick by brick, because it is wrong in a very specific and very interesting way. And the patches Penrose found are either the most important astronomical data of this century or an object lesson in how easily brilliant people can see faces in clouds. I am not going to pretend the second option is impossible. I am going to show you exactly how to tell the difference, and by the end you will understand something about the beginning of everything that most people who talk confidently about the Big Bang do not actually understand themselves. Here is the belief, stated the way a smart, curious person actually holds it. You know, the universe began about billion years ago. You know, it started unimaginably hot and dense and has been expanding and cooling ever since. You have probably heard the phrase, "The Big Bang was not an explosion in space. It was an explosion of space," and you nodded, because that is correct, and it is a genuinely good correction to the naive picture. From there, most people take one more step, and it is the step that breaks. They assume that because space and time began together, the question, what came before, is simply meaningless. Full stop. End of discussion. The way asking about a color north of purple is meaningless. It feels airtight. It is taught that way in documentaries. And it is not quite right, for a reason that has nothing to do with mysticism and everything to do with what our equations actually say when you push them to their edge. Here is the specific gear that breaks. General relativity, the theory that describes gravity as the bending of space and time, works beautifully everywhere we have ever tested it, from the orbit of Mercury to the bending of starlight to gravitational waves from colliding black holes. But run that same theory backward toward the Big Bang, and the equations do not gently fade to nothing. They blow up. Density approaches infinity. Curvature approaches infinity. The mathematics stops producing numbers and starts producing nonsense, a condition physicists call a singularity. And here's the part that gets skipped in the documentary version. A singularity is not a discovery about reality. It is a signal that your theory has stopped being able to describe reality. When your equations output infinity, that is not the universe telling you something profound. That is your equations tapping out. General relativity, on its own, is not actually saying time began here. It is saying, I do not know what happened here. Please consult a different theory. And we do not yet have that other theory fully worked out. That is the honest state of physics, and it is far stranger than the neat version you were handed in school. So when someone says with total confidence that time began at the Big Bang, full stop, they are not reporting a measurement. They are reporting the boundary of one incomplete theory as if it were the boundary of reality itself. That distinction is the entire hinge of everything that follows. So sit with it for a second, because we are about to build the correct picture on top of it, one piece at a time, and I promise you it gets stranger before it gets clearer. Let's rebuild this properly, starting from what we actually know rather than what we assume. We know the universe was, at some very early moment, extraordinarily hot, dense, and close to uniform. We know it has been expanding and cooling for billion years, and we know this because multiple independent lines of evidence agree on that number. The rate at which distant galaxies are receding, the abundance of light elements like helium and deuterium forged in the first few minutes, and the fine structure of the cosmic microwave background, the afterglow those Bell Labs engineers stumbled into. All three of those methods were developed independently by different people using different physics, and they converge on the same age within a few percent of each other. That kind of convergence is what makes cosmologists confident the basic Big Bang picture, the expansion and cooling part, is correct. Nobody serious is arguing about that. What is genuinely uncertain is the very first instant, the part before even the elements formed, the part general relativity cannot describe on its own. And this is where I want to plant something and come back to it, because it will not make sense yet, and it is not supposed to. In that same early universe, in the same afterglow map, there is a pattern of temperature variation so faint, so precisely structured, that it required a space telescope named Planck, launched in Hanging to map it in enough detail to argue about. Hindiat patches in that map are unusually hot. Some of them are almost 6 times brighter than the statistical noise around them should allow. Hold on to that number. We are coming back to it in a few minutes, and when we do, it is going to reframe everything I just told you about singularities. Here is where I need to give you an anchor, because everything I have said so far is abstract, and abstraction is where trust goes to die in an audience. Early in my own training, I spent a long stretch working with systems where the underlying mechanism was hidden and all you had were noisy signals, the kind of work where you learn, painfully, that a pattern jumping out at you from data is the least trustworthy moment in the entire process, not the most trustworthy. The human eye is a phenomenal pattern detector and an atrocious statistician. It will find a face in a wood grain, a word in static, a conspiracy in a coincidence, with total sincerity and zero malice. The discipline of actual science is not having good intuitions. It is building the machinery that catches your own good intuitions lying to you. That lesson is going to matter enormously in about 10 minutes, when we get to the part where a very smart person's intuition and the data start to disagree with each other in public. Let's close the loop I opened. Those 20 bright patches are the reason a small number of physicists, led by Roger Penrose, argue we might already have physical evidence of something existing before our Big Bang. Their model is called conformal cyclic cosmology, and the core idea, stripped of its mathematics, goes like this. As the universe expands forever into the deep future, all matter eventually either falls into black holes or decays away, and all black holes eventually evaporate through a slow quantum process called Hawking radiation, first predicted by Stephen Hawking. In the unimaginably distant future, Penrose argues, the universe becomes a cold, empty, expanding space containing nothing but massless radiation. And a universe made of nothing but massless radiation, it turns out, has a strange mathematical property. It no longer has a meaningful sense of scale. Without mass, there is no ruler, no clock, nothing to measure size or time against. And a universe with no sense of scale, Penrose argues, is mathematically indistinguishable from the hot, dense, scaleless conditions at the birth of a new Big Bang. In his model, our universe is not the first. It is one link in an endless chain, what he calls an eon, and the fireworks from the largest black hole evaporations at the end of the previous eon should leave a faint, specific fingerprint in the afterglow of the next one. Those 28 hot patches, in this picture, are not statistical noise. They are the last light of black holes that died in a universe before ours, whose radiation punched through into our own Big Bang. That is what a signal older than the universe actually means, and it is a real, published, peer-reviewed claim from a Nobel Prize-winning physicist, not a fringe theory from the internet. Now here is the section where I have to be the person in the room who slows everything down, because this is exactly the moment where the pattern recognition problem I mentioned earlier becomes the whole story. When Penrose and his collaborators first published a version of this claim in Hanging using an earlier satellite's data, another team of cosmologists reanalyzed the exact same sky maps using standard statistical methods and found the pattern disappeared. It was not there when you controlled for the ordinary properties of how the data was processed. The claimed signal, in that first round, did not survive contact with more careful statistics. Penrose's team came back in with the Hawking points claim specifically to answer that criticism using newer Planck data and a more targeted search. And once again, other cosmologists ran their own analysis of the same 28 patches and argued the excess brightness is consistent with what you would expect from ordinary statistical fluctuation once you account for how many places you looked across the entire sky. This is not a small technical quibble. It is the central question. If you search a big enough map for bright spots, you will find some. The same way if you stare at a stretch of highway static long enough, you will start seeing shapes. The unresolved argument, right now, is whether Penrose's 28 patches are signal or are exactly the kind of thing my earlier training taught me to distrust most. A pattern the eye insists is meaningful and the statistics cannot confirm. I want to tell you honestly that this is the part of the story that unsettles me, and not in the comfortable science is always asking new questions way people say when they want to sound wise without saying anything. It unsettles me because I do not currently know how to close this argument, and neither, as far as I can tell, does anyone else. I have spent a long time believing that good ideas eventually win the argument once enough data comes in. But this dispute has now run for over a decade through 2 separate satellite datasets, and it has not resolved. It has hardened into 2 camps who trust the same numbers and reach opposite conclusions, and I genuinely do not know which side time is going to vindicate. That is not me hedging for effect. That is the actual state of the field. And if a video tells you with total confidence that Penrose has proven a universe before ours, or with total confidence that he has been debunked, that video is selling you certainty the data does not currently support. But notice what this argument has already done to the original wrong idea, regardless of how it resolves. Remember the belief we started with. Time began at the Big Bang, full stop, and asking what came before is a category error, like asking what is north of the North Pole. That belief cannot survive the fact that serious physicists are running actual statistical tests on actual satellite data specifically designed to detect evidence of a before. You do not build a testable, falsifiable, data-driven search for something that is a grammatical error. Category errors are not confirmed or refuted by telescopes. The mere existence of this entire scientific argument, independent of who eventually wins it, proves that what came before the Big Bang moved out of the category of nonsense questions and into the category of open empirical questions sometime in the last 50 years, and most people have not caught up to that shift. Let's take the next hit at the same idea from a completely different angle, because I promised you 5, and we are only on the second. There is a second, entirely separate line of physics pointing the same direction, and it does not depend on Penrose being right about anything. It comes from quantum cosmology, the attempt to apply quantum mechanics, not just general relativity, to the earliest universe. In several of these frameworks, developed by researchers including Martin Bojewoldt working on what is called loop quantum cosmology, the infinite density that breaks Einstein's equations simply does not occur. Space itself, in these models, has a smallest possible size, a quantum floor it cannot be compressed below, the way there is a smallest possible unit of electric charge. When you rerun the collapse of a universe toward the Big Bang using these rules, the density approaches an enormous but finite maximum, and then, instead of a singularity, the model predicts a bounds. Contraction reverses into expansion. In this class of theories, there is a literal before, a prior contracting phase of the universe that turned around, not a metaphor for one. These models are far from proven. But they exist. They are mathematically consistent. They do not require infinities, and they were built by physicists working completely independently of Penrose, using different mathematics, arriving at compatible conclusions about the same basic point. General relativity's singularity was never proof of an absolute beginning. It was a sign that general relativity alone was the wrong tool for that specific job. The same way a bathroom scale reading infinity when you try to weigh a mountain is not evidence the mountain has no weight. It is evidence you brought the wrong instrument. Here is where I want to open something and make you wait for it properly, because it is worth the wait. If the Big Bang was not necessarily an absolute beginning, if it might instead be one event in a longer, hidden history, then the natural next question is whether we could ever actually detect anything from that earlier history directly, rather than arguing about faint patches in an afterglow that everyone agrees is ambiguous. It turns out there is a candidate for exactly that, and it does not depend on Penrose or on quantum bounces at all. It depends on gravity itself leaving fingerprints, and it is, in my opinion, the most underrated piece of this entire puzzle. That candidate is called the primordial gravitational wave background, and here is the mechanism, built up properly rather than gestured at. Einstein's general relativity predicts that violent enough events warp space and time so sharply that ripples propagate outward through the fabric of the universe itself. Gravitational waves, first directly detected in Hangyan-Kumchumwelam from high colliding black holes over 1 billion light-years away, a detection so precise it measured a change in distance smaller than 1/10,000th the width of a proton. Now take that same mechanism and run it all the way back to whatever violent process actually kicked off our observable expansion, whether that is cosmic inflation, a Penrose-Steiner-Ian transition, or a quantum bounce. Any sufficiently violent event in the deep past should have generated its own gravitational waves, and unlike light, gravitational waves barely interact with matter at all. Light from the very early universe gets scattered and absorbed and reprocessed by the hot dense plasma that filled space for its first years, which is exactly why the cosmic microwave background is the earliest light we can ever see. It is a wall, not a window. Gravitational waves, by contrast, sail through that same plasma essentially untouched. A primordial gravitational wave background, if we could detect it, would be a direct signal from earlier than the earliest light, a message that did not have to pass through the wall at all. We have not detected it yet, and the reason we have not is itself worth understanding, because it explains why this search has taken decades rather than years. The gravitational wave detectors that caught colliding black holes in Hangyan-Kumchumwelam, instruments called LIGO, work by splitting a laser beam down 2 perpendicular arms each 4 kilometers long, bouncing it off mirrors, and recombining it, watching for the almost impossibly tiny mismatch a passing wave creates. That design is built to catch fast, sharp ripples, waves that oscillate many times per second. A primordial background from the very early universe would stretch space far more slowly, over years rather than milliseconds, which means no laser interferometer on Earth is built with the right kind of ruler to see it. You need something that oscillates on the timescale of years, and it turns out nature already built one, scattered across the galaxy. Pulsars, the collapsed cores of dead stars, spinning hundreds of times a second and flashing a beam of radio waves toward Earth with the regularity of an atomic clock. If a slow gravitational wave passes between us and a pulsar, it stretches and compresses the space the signal travels through, and the pulsar's tick arrives at Earth a fraction of a microsecond early or late, in a very specific pattern shared across every pulsar in the sky at once. In Hangyan-Kumchumwelam, an international collaboration monitoring dozens of these pulsars for over 5 years announced they had found exactly that shared pattern, evidence consistent with an enormous background of extremely long gravitational waves washing continuously through the galaxy. Nobody yet knows for certain what generated it. It might come from pairs of colliding supermassive black holes, an origin with nothing to do with the birth of the universe at all. But dedicated future missions, including proposed space-based detectors with arms millions of kilometers long, are being designed specifically to hunt in the frequency range where a genuinely primordial signal, one from before or during whatever process kicked off our observable universe, would have to live if it exists. That is the loop closing. If that hunt succeeds, we stop arguing about ambiguous bright patches in 380,000-year-old light. We get a direct physical signal that passed through the one era of the universe that has always been sealed off from us, and the question of what happened before the Big Bang moves out of statistics and philosophy and into direct measurement. The same way Einstein's prediction of gravitational waves sat unconfirmed for 99 years until an instrument sensitive enough to catch one finally existed. There is a fourth angle worth taking, and it comes from the strangest corner of this whole argument. The question of why time only ever seems to run in one direction. You experience the past as fixed and the future as open. An egg cracks and scrambles. It never unscrambles itself back into an egg. Physicists explain this using a quantity called entropy, roughly a measure of disorder, and the rule, called the second law of thermodynamics, says entropy only increases as time moves forward. But here is the detail almost nobody sits with long enough. For entropy to have been increasing this entire history, it had to start low. Our universe began in a state of almost absurdly low entropy, a state so improbable, so exquisitely ordered, that some physicists, including Roger Penrose again, working from an entirely separate line of reasoning decades before Hawking points, argued this demands its own explanation. An ordinary random event does not produce a low entropy starting condition. It produces a high entropy one, the same way shaking a sealed box of puzzle pieces does not spontaneously assemble the picture. Something about the Big Bang was special, ordered, improbable, in a way that plain randomness does not explain. And time itself began in a featureless instant with no prior cause, does not actually resolve why that instant happened to be so exceptionally, suspiciously tidy. A true, absolute beginning from literal nothing has no obligation to be orderly. Ours was. That mismatch is a fourth independent crack in the same wall, arrived at through thermodynamics rather than telescopes or quantum gravity, and it points the same direction as the other three. Something set up the conditions we started from, and nothing, then suddenly everything, for no reason, in a state far too orderly to expect, is not an explanation. It is a placeholder where an explanation should go. I want to pause here and give you the second anchor I promised, because abstraction has been piling up and you deserve a breath of something concrete. Years ago, working through a stretch of failed models in a completely unrelated part of my training, I remember the specific, physical feeling of being wrong for months in a way that felt like being right. That is the part nobody warns you about. Being wrong does not usually feel like confusion. It feels like clarity, right up until the moment the data finally forces the correction, and then it feels like betrayal, because your own mind was the thing that lied to you most convincingly. I bring this up now, in the middle of this argument, because I want you watching your own reaction to everything I have said so far with a little more suspicion than usual. If any part of this has felt too satisfying, too tidy, too much like it confirms something you already wanted to believe about mystery and wonder and the universe being bigger than we think, that feeling is not evidence. It is exactly the feeling that has fooled better scientists than either of us, and it is the same feeling that makes Penrose's 28 patches so seductive whether or not they turn out to be real. I want to give you the version of this that should genuinely unsettle you, the one that goes past trivia and into something closer to vertigo, because we have earned it by this point. If any of these approaches is even roughly on the right track, then the number billion years, the number that gets treated as the total lifespan of existence itself, the number printed in textbooks under a single triumphant heading, is not the age of everything. It is the age of the most recent chapter. It would be the equivalent of dating a book's story to the moment the current page began, while entire prior chapters, an entire prior history of expansion and collapse and black holes and evaporation, sit just before the page you happen to be standing on, permanently written, permanently real, and permanently out of reach of direct sight, readable only through the faintest fingerprints leaking across. The binding. The universe would not be young. It would simply be the part of something much older that light happens to let us see. Now take a step back and notice the shape of everything I have just walked you through, because it is the fifth angle on the same target, and it is the one that ties the other four together. The wrong idea was never really about the Big Bang specifically. It was about a much more general and much more comfortable habit of mind. The assumption that when our best theory hits a wall, the wall must be a feature of reality rather than a feature of the theory. We do this constantly, in every field, not just cosmology. Our model breaks down, and instead of saying our model has reached its limit, we say reality has reached its limit, because the second sentence feels like a discovery and the first sentence feels like an admission of ignorance. But every major advance in the history of physics has come from refusing to make that substitution. Newton's gravity, published in 1932, broke down near the enormous mass of the Sun and near very high speeds, predicting the orbit of Mercury slightly wrong by a stubborn arcseconds per century that nobody could explain for over 200 years. Physicists did not conclude that Mercury's orbit was simply unknowable, a mystery beyond the reach of science. Einstein built general relativity in 1911, and it accounted for that exact 1.2 arcseconds precisely on the first try. Classical physics broke down completely inside the atom in the early 20th century, predicting that every atom in existence should collapse in a fraction of a second as its orbiting electron radiated away its energy and spiraled into the nucleus. Physicists did not conclude the atom's interior was forever closed to us. They built quantum mechanics, and it explained not only why atoms are stable, but why chemistry itself works the way it does. The pattern repeats so consistently across 300 years of physics that it stops looking like coincidence and starts looking like a law of its own. The wall was never the edge of reality. It was the edge of the current map. The Big Bang singularity is very likely the same kind of wall, encountered by a theory that is magnificent everywhere else and simply was not built to survive its own most extreme edge. And the honest, exciting answer is not here there be nothing. It is, we do not yet have the right map for this specific territory, and there are at least 4 independent, serious, mutually reinforcing research programs. Racing to draw one, using data from satellites, pulsars, quantum gravity, and thermodynamics that were never designed to talk to each other and are somehow pointing the same direction anyway. And this is exactly why the closing question is not really about physics at all, not anymore. It is about what kind of confidence you are willing to mistake for knowledge. The people who tell you with total certainty that nothing came before the Big Bang are making the same error as the people who will tell you with total certainty that Penrose has already proven it did. Both groups have stopped doing science and started doing storytelling, because the honest answer, the only answer the actual data supports right now, is that we do not know. We have several serious, competing, testable ideas about how to find out, and the very fact that the question is testable at all is the single most important thing anyone told you today. So here is where this really lands, and I want you to sit with it rather than not past it. You came into this video thinking you were being told about a strange signal in old light. You were actually being told something about the shape of your own certainty. Every time in the history of this species that someone has said, this is where knowledge ends, beyond this there is nothing to ask, they have eventually been proven not prophetic, but simply early, standing at a wall someone else later walked straight through. The Big Bang was never the edge of reality. It was only ever the edge of how far our instruments had learned to see. And the moment you understood that, you already knew, before I ever said it, that the universe was never going to be small enough to fit inside our confidence about it.